Okay, ladies and gentlemen, very good afternoon to you all. Thanks for being here. We're going into a very interesting field of hacking, actually hacking people. Well, how should I say, fixing people rather. We're talking about prosthetics. Now, prosthetics is when you crash your bike and you lose your leg and you get another technical one. That's the typical use of prosthetics in the West. There are other countries, war-torn countries, countries with a lot of natural disasters, developing countries where basic health care is not at Western standards. These people have health problems with diabetes, gangrenes, infections. In war-torn zones, we all know the stories about landmines. And there are other areas where, due to massive natural disasters, landslides, earthquakes, people get wounded. People have to cut their legs off, their arms off, and unless here, where we've got health insurance that at least pays you a basic prosthetic implement at the cost of some 2,000 euros, maybe. They don't have health insurance. They don't have the money to buy these expensive implements that we've got. We've been working together here at Amsterdam Fab Lab with a group in Yogyakarta. HONF, they're called. HONF is an abbreviation for the House of Natural Fiber. The House of Natural Fiber came to us to learn about prosthetics. Because, you know, here we do, we create these implements at costs of 50,000 or even 200,000 euros per piece. They wanted to know how do we do that, and they wanted to find a way how they could implement making prosthetic implements there in Indonesia at a very much lower price. But first, of course, they had to understand what our high-tech implements are all about. And this is a short film, and I would now need the audio of the laptop, please. Avi, alsjeblieft, kan ik even... Hey, kan ik even het geluid van mijn laptop hebben? Dankjewel. This is a promo film of a modern high-tech arm implement controlled by the nerves through electronics. I suspect that the whole film is some kind of clever animation. That's where technicians and biomedics want to be in a couple of years' time. But technically, this kind of thing is certainly doable.
The world's fastest, most powerful body upgrade.
To just show you where we are at the moment, a very short clip from Touch Bionics with a guy actually using an implement that he controls with the nerves that are still living in his arm.
Yeah, since sitting here with this limb, it is really like being reborn, you know, but even seeing it, and it's a big learning curve again, because the learning curve for me was learning to walk and learning to use just normal, you know, standard fitting limbs, but this is something incredibly special. And at the age of 53, I think that's pretty good, I think. My kids will be in awe. I mean, everyone around the road will want to come and see me. I mean, it won't be a freak show because I just think that's fantastic. I do. And I think if I can master this, I'll be able to cut my food up.
Right, so that's the real thing. That's technology we can deploy in the West. And here you see a number of other pictures of how these implements are actually tested and used in a lab. That's obviously the parts of these implements. You see joints, you see all types of pretty high-tech, high-quality stainless steel things. Here you see a number of foots for walking, foots for running. You've certainly seen pictures of these legs. They come at a pretty high price, 10,000 euros, one of them. Here you see them as we were playing around with these implements at our lab. Very different story. We moved to India. In India, there is a company, Jaipur Foot, and they produce lower leg prostheses at a much lower cost. They are able to reduce the cost to something.
Just of the leaf head pressure are marked, then the soaked POP bandage is wrapped around the stump. The anterior and lateral alignment axes are marked. The negative cast is removed from the stump. This cast is fixed on a wall frame and the mandrel is put in the center of the cast in reference to the alignment axis. The alignment of this cast is reconfirmed by the laser line system. Then this negative cast is filled with the plaster of Paris paste. The wall frame is obtained from Endolite, a British company, and the laser alignment system is from Ottobock, a German company. To get the best alignment, BMVSS has married these two different systems. As the POP paste solidifies, the negative cast is cut open and a positive mold is thus obtained. This is modified as per the markings, which are marked at the time of taking the measurement, and is given the exact shape of the stump of the amputees. This modified positive cast is then fixed on a vacuum forming machine. This is then covered with a heated EVA sheet, which is formed by vacuum to get an exact fitting soft insert. Now this positive cast, covered with EVA soft insert, is again placed over the vacuum forming machine. This is now draped with a heated HDPE sheet, which is again vacuum formed to get the exact shape of the stump, providing excellent stump socket interface. BMVSS has imported the total vacuum forming system from Germany to get closest fitting sockets. This HDPE covered positive mold is again fixed on an alignment apparatus and it is extended into a full prosthesis size. This extended positive mold is again brought into the draping room and is fixed over a vise. A HDPE pipe of the skin color is heated in an oven, and when it is sufficiently malleable, it is sleeved over this extended mold. The plaster is then removed, and the extra material from this limb is also removed. A Jaipur foot and a belt is then fitted to it. This prosthesis is then worn by the patient and the height of the prosthesis is checked. The prosthesis is then checked on a static alignment apparatus and is then given to the patient. The gait of the patient is checked. If any correction is to be done, it is done at this stage.
So that's how they do it in India, and such a foot costs around $500. That's still about 1.5 times the annual income of these guys in Yogyakarta. So to really be able to produce these kind of implements there, there is another cost reduction needed, and that's what these guys from Honf are aiming at. You see, they are making these prostheses in a traditional way, but they are still 3 times heavier than the high-tech stuff that we can get here in the West. It still involves a lot of manual labor, and the quality is kind of difficult to keep at the constant level. So they came to a visit here in Amsterdam, and well, not here in Amsterdam, but here in the Netherlands. They came to Amsterdam, had a look at our fab lab and the possibilities that they could get with such a laboratory full of machines to make almost anything. They had a full-day session with Appie Rietveld. He's a guy who had one of these motorcycle accidents, and he is now a long-distance runner with an artificial leg. They went to visit a company who actually works in the area of orthopedics and makes this kind of stuff. Another company, Kamer, they produce actually these kind of feet. And they learned quite a number of things, and I'd like to highlight just one thing here, that the whole alignment of the artificial implement to the natural body of the patient is highly crucial, so that the forces that we normally can sustain with our limbs can also be sustained with the prosthesis. At the end of their visit, and with the knowledge they have themselves, with the knowledge they got from the Fab Lab, they believed that they will be able to produce cheap, long-lasting comfort prosthetics at a price of only $50, which is amazing. And that was in spring this year. What I'm now trying to do is to connect to Yogyakarta in Indonesia. Oh, you can see it and I can't. What a shame. They're saying they're ready. So I call Yogyakarta. Hey, Tommy. Hey, guys.
Hello. Hello.
How are you doing? Try to, I'm not trying to do any silly things now, like tilting my laptop to show the crowds and so on.
Okay.
I just told them that you have been with us in Amsterdam to learn a lot about prosthetics, and that then you went home to take that idea further. Now, what have you done in the meantime?
My name is Tony, and this is Ira from House of Natural Fiber. So, as what Peter explained about our project during his visit in Fab Lab in Amsterdam, we not only the machine in Fab Lab Amsterdam, but we also get some knowledge and information, etc., from Dr. Marcel Conrad, the Foxtrot Orthopedic, and also Mr. Kamer from Kamer Orthopedic, and also Appie Rietveld is one of the prosthetic user. So continue what we have learned during this stay in Amsterdam. We intensively talk with Yakum Rehabilitation Center in Yogyakarta, But I'm sorry that for today I cannot present the director of Yakum Rehabilitation Center to talk with all of us here. But more or less, maybe what Peter explained about Yakum Rehabilitation Center and what they do is, I think, is more or less represent what is Yakum is. So maybe we continue with what we have progress with Yakum. That during our last meeting with the director and all the Yakum staff, we have a lot of input from them that they do making prosthetic and also they they do the not only prosthetic, they also do orthostic, and also they design some bicycle which is called tricycle only for the disabled people, which is the handle is all come with the hand. And also they modified some wheelchairs that will suit for young clients. But they have also some division that they want to build a prosthetic component that they dream to be one of the prosthetic component supplier in Indonesia. So,
okay, Tommy, I think I'm losing you there. I'm trying to reconnect. And Tommy, I might suggest that we don't use video at that moment to spare some bandwidth. No, don't refuse me.
hello.
Hi, Tommy, you're back.
Okay.
Can I suggest?
Sorry for Indonesian action.
Can I suggest that you don't use the video camera at the moment?
Okay.
And I then would like to show the people here the photos that you just sent over. I think they're sitting somewhere on my desktop.
Yes. So from the picture that I have sent you, one of it is a laser alignment for adjusting the disabled people. That Yakum will never buy this kind of device because it's very expensive for them. So what we have meeting with Yakum, also Alex Shaw have also a meeting with all home and also with the director of Yakum staff, that we plan to build or re-engineer the laser alignment with the tools and also with the equipment that Fab Lab have to re-engineer the laser alignment so that Yakum someday have their own laser alignment. Sorry, our office is a plane pad. So, yeah, it's like every day we hear a plane coming above our office. So continue what we will do in the future with the engineering the laser alignment for Yakum is one of our goal of project. So the general is that we don't only provide them with the equipment or tools to very useful for them to create components or parts or something like that. So that's one of our project. And the other one is we will create another alternative join for component of prostate, which is nowadays Yakum usually import from China, and also they're trying to produce themselves, but it's not compatible with the market yet because the quality and also the quantity that they can afford is less than the market demanding. So we are thinking about the alternative joint or alternative components, and also we trying to do material research, which is come from local material, which is we can found in Yogyakarta or in Indonesia, that in the future we can use this local material, which is cheaper and more easier for Yakum to develop prosthetic, orthestic, and also component. So the other project is that we will develop a 3D scanning portable for Yakum, so that this device will be owned by Yakum, that maybe that they can use this 3D scan. They can come to the client, which is the client is mostly from the village and also come from the poor level of societies in here. So Yakum can bring this 3D scanning portable device to client in their home, and they can do alignment, they can do the scanning and etc. And they will have this information, and they have the measurement, alignment, and everything, so that they can develop the prosthetic for this client in Yakum workshop and also in Fab Lab workshop in future. So yeah, basically that's most of our project in the future that we would like to work with Yakum. So maybe you want to add.
Excellent, Tommy. Thank you very much. That's an excellent and very interesting upgrade on the progress you made. So what are the next steps actually that you're really going to do? When are we going to see, the first implement? And I've lost connection again. Trying to get him back again. Hi, Tommy.
Hello.
So my question is, when are we finally going to see the first prosthetic implement that you have produced down there in Yogyakarta? What's your estimate?
Okay.
And now we're still in progress to do some research about the condition in here, what they need, and what the thing we can find here, and some partner that we can collaborate.
Yeah, and but maybe there is one idea that maybe you have the link from the YouTube that you can show to the audience about the bicycle parts prosthetic. If you have the link, Peter.
Yes,
so,
I do have it.
Yes,
I'll just fire it up and show it here.
Yeah. This is one of the most possible kind of prosthetic that we can develop in very short time. But we plan, after the research of material, research of parts and everything, we plan to have one of the developed prosthetic which is cheapest prosthetic, maybe in the beginning of 2010. So this is the most possible schedule for us.
Also for Yakum.
and also for Yakum. But for the bicycle parts type of prosthetic, this is the most possible kind of prosthetic that we can develop in very short time, because we have all the bicycle components in here, and we have like second hand bicycle and parts and components. And also we have found the extra material that we will use it, like kind of, if you know, kind of material that we always use for a mouse pad, which is we can find it here as well, so we can use it for the bicycle parts prosthetic. So
Okay, Tommy, thank you. The connection line is dropping again, so I think we leave it there at the moment. I'm not quite sure if we would be able to handle question and answer sessions with participation of Yogyakarta. Here they come again.
hello.
Hello, Tommy. I guess the connection is that shaky at the moment that I suggest to wrap it up at this very moment. Thank you very much, Tommy, for being with us and sharing your progress. And I'm sure there will be another occasion in another month or two to get back to you and see what you have done with this bicycle prosthetic implement.
Yes.
Thank you very much, Tommy. It was a pleasure to have you here. Good night.
Thank you, everybody.
Bye. Okay, ladies and gentlemen, I think I'll wrap up my presentation right here. Does anybody of you has an urgent question that we would need to answer right now? The cost in Europe is not going down because the tendency in Europe or in the West in general is going into more high-tech, more nerve-controlled, more sophisticated, while in the developing countries it's really just the need to just get these implements.
Yeah, but you have multiple handicapped people and children that probably won't actually use the high-tech stuff, so it could be a solution for them.
It could very well be a solution, certainly. Well,
healthcare is getting reductions on reductions on reductions on what they can invest for those people.
This is an interesting point. So, yeah, we might want to pick that one up. More questions?
Hi, you've talked about lower leg prosthetics, but is there any possibility of a €50 arm prosthetic? What is the difference in technology between the leg and the arm?
We started with obviously with the lower leg implement because that's where most we've got the biggest number of patients. We would probably have to look into the arm and hand implement very closely to see what would be achievable in terms of, we would be talking about kind of a fixed lower arm implement, not like moving fingers and that kind of thing. Then certainly it would be possible to bring costs down there as well. More questions?
You may have censored.
thanks. How did it all come about? Like, who contacted who, and where did that begin, that process?
Ooh, I can't really remember what was first, but it's kind of an ongoing story with this group in Indonesia. They're active in very many fields, not only in healthcare and rehabilitation. They're also artists. They do all kind of weird stuff there. So it was kind of, if I remember correctly, it was kind of an ongoing thing. The idea to let them have a fab lab, and then from that the idea came up: oh, what could we use that fab lab for? Oh, there is a big demand in this area. So I guess that's how the project came about. Any other questions? If that's not the case, then thank you very much. Thank you for being with us. At 3 o'clock, I guess there will be the next session here, which is the iBorg project. So again, hacking people. Thank you very much.